Hello everyone. This is Wednesday on January 31. Adam and I both have off work on our full-time jobs until next Monday. So we thought we would use this time as an opportunity hopefully to get hopefully a month's worth of videos, try to get one a week out. And so we got quite a few of them that are planned. I'll just go over some of them shortly. I posted on Instagram some pictures of some things that are coming up. Here's a little unit that I made just in the last few days. What we have over here, we have a half 20 thread, and then from here on into this nut we have a half 20.16, and this is what they call a differential screw. They're kind of new to me. Tom Lipton and Robin Renzini, they both have videos that talk about them a little bit. So I don't know if this is going to work, but I'm going to give it a try. So basically what will happen is in this screw at a 20 threads per inch, when you turn this screw, it will move 50 thousandths per revolution. And if you're threaded in something over here at 20.16, it will pull this back 49 thousandths and 6/10. And so what you're going to end up with is per revolution, you're going to have a 4/10 adjustment. Now there's play in this and everything. I'm going to try to use springs and keep everything to one side. And what I'm going to use this for is I plan on building a little fixture that we can use on the surface grinder that can grind between centers. If you watch some of Stan's videos, he just bought him a Herrick one. Those are real nice units. I've used those many times in the past. They're really super units, but they're quite expensive. And so I wanted to build one, and I wanted to try some things out. And I plan on using this system to see how well I can adjust the center height on that. And so I don't know if it's going to work, but I'm going to give it a try. I think it's going to be fun. So we'll probably have a series of videos that I will show the build, how we're going to go through that. I'm in the design process right now, so it's not going to be anything that's going to happen real sudden. One of the videos we're going to have, I'm just going to get this seated into something, a couple blocks, kind of with that spring pressure like I was talking about, and then I'm just going to try the adjustment and see how well it works. And then we'll go from there. And so that'll be a multi-part video, and it will probably be over the next 6 months or so. We'll see. Another video that we plan on doing is if you've seen some of our previous videos, we'll put some links to them. We have a Planet 550 air spindle. This rotates, I think, at pretty close to 60,000 RPMs if I remember. And in our videos we had that mounted with the unit over here on the surface grinder, and by using the spin fixture in there we can actually do jig grinding, and we can do some ID grinding, some real precision work. Well, one thing I've never tried and I've been curious about is to use that unit and grind in closed slots. Something that you can't set on the surface grinder because it's enclosed. But use it to grind slots and see how accurate that I can do with that. And so that'll be a video that we'll learn together on and see how it works. And this video, what we want to do is we want to talk about using your spin fixture. We have a Herrick spin fixture. It's actually a pretty nice one. It's motorized, and the accuracy is not as exacting as I want, but it's good for probably plus or minus 1/10. And it does, you can put 5C collets. I built face plates and V-blocks. Eventually we'll probably have a lathe chuck, a smaller one on it that's adjustable. So that comes in handy for a lot of things. But one of the problems that you'll find when you're doing OD grinding on a surface grinder sometimes getting the taper worked out is not too bad, but a lot of times you're going to end up with a dip in the middle. You're going to end up with an hourglass figure. And it's quite common, and you can struggle with it, and sometimes you can pull your hair trying to figure out how to get that out. Stan had that issue in one of the videos that he had where he was truing up a cylinder square for Keith Rucker, and he was struggling with it, so I had a lot of steps that he went through to eliminate that. But one of the common ones that you'll see is what happens is when you're grinding, and if things aren't lined up perfect on your y-axis as you travel across here in the center line of your spindle, depending on where your point of contact from the tangent of this wheel to the diameter over here is, if you have it say in the middle, and if everything's lined up real good and you can come across, you should grind and not have any taper. But what happens is all of a sudden you're twisted, you have your low point right here, and you come off and you're at an angle. What happens is the tangent point off this wheel, it touches at the center, but it's not touching at this end, it's off this side, and on this end, it's on that side. And so that you're further from the center line, and what happens is this diameter will become bigger, this diameter will be bigger, and it will be small in the middle. And it doesn't take a whole lot to be off center before you end up fighting a tenth or two, or if I remember right with Stan, it was like 50 millionths, and his is probably some other reason than what we're covering here today, but that hourglass figure, he had that problem, and that's why it kind of got me thinking about this, because I know some of the other reasons why this may happen. So anyways, what we're going to do, we're going to set a part up. I already have it on the grinder. I already got a piece of coal roll. It's about 1 inch diameter, and I already got it ground, and I got everything set so that the taper is out, so I can demonstrate some of the problems that you have when you're grinding and how you can compensate. And so let's go over here to the grinder, and what we're going to do, we'll measure the part, and Adam's going to have to hand hold the camera, and hopefully he can get in positions where he can show you what's going on over there a little bit. And hopefully it'll work out, and you guys can see what we're wanting to demonstrate. This is a Herrick fixture. It's motorized. This actually works pretty nice. We built the base on here. I have this set up so that I can adjust taper out by making the front come up or down, and so that works really good. And so off camera already, I got this set up so that I could grind this shaft and that I can get the taper out, and we'll just measure and show you where it's at right now. I almost wish that I would have ground this on camera just to show you how nice that tapered adjustment, that just a 1/4-20 screw works down there. On this end, we're 9/34 5/10, and I'm not sure if Adam's capturing that in the camera or not, but we'll see. I got to be careful, the wheel is on right here, so. And you can see we're 9/34 5/10. And let's see, let me get a good feel here. 9/34 5. And so you can see that in approximately 3 inches here, that thing's really straight. Now, one of the things that you have, if you buy your fixture instead of building your own, one of the things you got to remember, they're mass producing these, and you may have people of different skill levels. You may have them making these. What you want to make, and you may have to touch it up by grinding, you have a center line on your fixture that you want to be running perpendicular. If you're going to use a rail system, you want it to be running as perpendicular as you can with the front, parallel as much as you can on the side. Now on this fixture, I have it all mounted, and in the past I ground got taper free, and then what I have done is I lined it up really good with the side. So I can run an indicator on the side, I can use my rail on the front, and that's going to get me really close to lining my center line up with my y-axis. The other thing that you want to do if you're wanting to establish getting the taper out by adjusting this up and down, if you come and you're grinding and you're starting out on the center line of the wheel, and this axis or this center line is turned crooked, and depending on where it's at, you can end up with taper. So if you're touching on the center line on the back of the part, and it's not following, the center line of this is not following the Y traverse, you can end up with taper. It'll be bigger or smaller at the front depending on which way you are. And it's not an adjustment you're making this way. It's because what's happening is you're going off your, as you go down, you're going off your center line. And it's going to make you think that, oh, I got to adjust the taper out. Well, no, the thing you have to do, you almost have to adjust these taper kind of separately. So when you line this up, when you want to get the taper adjusted in this plane, you don't even want to be grinding on the center line of that wheel. You want to pull off center probably about 10 or 20 thousandths and then grind, and that way you know that you're not, if you're lined up close enough, you know you're not, as you're winding in your Y, you know that the tangency point of the wheel is not crossing the center line over here and giving you a reading that's throwing you off. So I'm going to show you a little technique that we use where you can get the center line right on if you want to grind that way. But I only use that technique so I can get on center line, and then I always like to pull to this side of the wheel 10, 20 thousandths and grind, so I eliminate the error that you're going to get is if the y-axis and the center line of the fixture is off a little bit. And then that way the only axis I have to work on with the taper is up and down rather than positioning here. It makes life a lot easier. So Adam's going to try to get in here, and he's going to try to get the video going and capture this. It's going to be hard because there's not a lot of clearance in here. I'm going to back off just a little bit, and I'm just going to ink this up over here a little bit. Now when I'm grinding on my ODs, I have this relieved so that about the width, a little more in the width of the wheel, because I want the wheel to be able to come all the way off on my grind. But if you don't have that option and you're grinding from a shoulder to something else, always come and start at this end of things and then grind with your wheel moving that direction. And then that way what happens is all the cutting action is taking place on the front of the wheel, and as the wheel breaks down, it's on the front, but as the back leaves your part, it should be cutting at the same diameter as it is at the front. If I'm coming this way and I'm coming up to a shoulder, and then my wheel's breaking down in the front, what's going to happen is I'm going to end up, whatever the width of my wheel is, it's not going to be the same as the rest of the part because the wheels broke down. So anyways, what you do is when you come up on center, to find center, you let me just barely touch. There, I'm just barely touching. I have the lock on here pretty good, but I can still move this. And so what I'm going to do, I'm wanting to move until the sparks, if I'm off that side. As I move the unit that way, the sparks will get heavier, and then as I cross the center line of my spindle, the sparks are going to get lighter. And so I can tell where I'm at on center, and hopefully we can capture this for you. I'm going to start right now. Okay, got to come down a little bit more. See, we're starting to spark. Now it's starting to go out, so now I can back up a little bit. I'm really close on center line right now. So at this point, I can just take, and if you want to set an indicator, I never do. I feel it, and I just want to be off center line just a little bit. And then I can come across and grind. And that's how I pick up center on a fixture like this. So now, because I'm off center, I don't have to worry about the center line of the wheel. If I'm out of alignment, I don't have to worry about it crossing over. So we already have this ground up nice and good. What I want to do is to demonstrate by turning this fixture. I'm going to turn this fixture slightly, and so that we're purposely going to be grinding so that our wheel is crossing the center line. Let's see. I'm going to raise that out of the way, and when I do this, I'm going to slide it, the whole unit out, away from under the wheel, because when I turn the magnet on residual, if for some reason this would kick and it would let loose, I don't want anything under that wheel. So there, I got it right there. Yeah, go ahead and hold that just a second, Adam. Oh, here it is right here. There we go. Now if you look where I have my angle with the back rail, what you can see is I got this exaggerated. We got quite the angle. I mean, it's not even eyeball close, but I'm doing this so that I can hopefully demonstrate to you the importance of lining everything up and then grinding about 20 thousandths off center of the wheel. So what I'm going to do, I'm going to try to roughly eyeball about center of my grind this way, and then I'm going to roughly eyeball the center, because what I want to cross on both sides. And I want to purposely make an hourglass shape right now. Going back and forth until it sparks out to get the center. And right there, we're about right there. I'm going to set zero here. I'm going to back her off a little bit. And we'll come over here. I'm going to have to take a little bit off because I dropped this in. I dropped the diameter down when I was showing you how to find center. So we're going to take a little bit off. The wheel's a little bit loaded, so finish isn't going to be that great. Oops. Gotta reset the Y. I knew I was close. Didn't know I was that close. Okay, let's see what it looks like. I don't know if you can see the numbers, but I'm reading 932 and 9.5 tenths. Over here I'm reading 931. You know, so over here. 932, 9.5, almost 933. Over here we're at 933, about 50 millionths difference. When I come over here, you can see I'm 932, 7.5. You can see that I'm dipped in the middle, and I'm high here, and I'm high here, and I'm low here for a few tenths. And it's quite forgiving. It depends on your diameter and everything. You can see I'm quite a ways off center. So it takes quite a bit. But like if you look in Stan's video, he's fighting for 50 millionths because he's grinding a cylinder square, and you want those as accurate as you can. And he figured his was heat buildup that was causing the problem over there. But when you're grinding on the OD, you got to remember 50 millionths, that's not a whole lot that you're going to have, because if I take off 1/10 off this side, I'm taking 2/10 off the diameter. So when he's talking at 50 millionths that's dipping in the middle, he's talking 25 millionths per side. So right here we can see we're a few tenths off. So, and that was positioning the center of my wheel right here. What I'm going to do now, I'm going to position the center of my wheel over here, and you're going to see that we're not going to have an hourglass figure, but we're going to end up with a taper. And again, just to illustrate what happens and why everything has to be lined up perfect to get good results. And even then, it would be wise to move off the center that direction, so that if the low spot of your wheel is always on that side of your work, if you grind off center about 10-20 thousandths, and then that way you never have to worry about the tangency point of that crossing your center line of your work. So let me get this set. We're going to leave the angle set just the way we have it. But right now, just keep in mind that we're high on both ends, we're low in the middle. And all I'm going to do now is shift the tangency point of my wheel to the center line of my spindle at this end down here. And you're going to see we're going to end up with different results. Now we're shifting there. I'm going to set 0. I'm going to just wind up again because I make sure that we're not going to take too heavy of a cut because the wheel is loading up. You know, I'm new to this YouTube machining community. I've only been started following some of these people probably less than the last 6 months, and I'm pretty amazed. There's a lot of talented people that have a lot to offer out on the YouTube, and I've learned a lot, and not only just from the YouTube creators, just the comments that our subscribers and viewers, what they write. I've been actually learning quite a bit, and I appreciate it when you guys will share some of your secrets. They say you can't teach an old dog new tricks, but I'm going to break that mold. I like to learn, and if I stop learning, I might as well die as far as I'm concerned. And you can see what we just did here. We're hitting heavy on this end, and we're not hitting on the back side, so that's good. But anyways, from time to time, I just want to mention some of the people that are out there, some of the YouTubes that I find value in for different reasons. Some of it might be just entertainment. Some of it might, they're possessing the skill set that I lack in and I want to learn from. Some of the stuff, you know, is new to me. I mean, there's various reasons. Just it might be neat, some of the things they're doing. Any of you that have watched our older videos, you'll see that in many of them, you can know I'm a big fan of Fusion 360. Now, I'm not getting any money from Fusion 360 or any kickbacks. The only thing I'm getting, which everybody can get, is a free subscription, the last I knew, because of the fact that we make less than $100,000 a year. Actually, we haven't, I think the only money we made so far, and we haven't been paid, we made about $95 with the monetizing on YouTube for the last 2 months. We don't look to get rich on that way, but we just thought it would help cover some of the costs. Adam he has about $2,500 invested in sound and camera equipment, and he wants to do even more. So we just thought that it would help out that way. But anyways, I'm a fan of Fusion 360, and there's a couple guys out there, they don't have a terrible lot of subscribers, but they got some excellent content. And one of them is Mechanical Advantage. The guy that's doing that's named Kevin, and if you want to learn Fusion 360, he's got some great tutorials online there on the YouTube, and it can really speed you up. You can get in there and you can start learning the ins and outs of Fusion 360, and so I've been telling my boys they need to check those channels out. You get one computer laptop where they're playing his video, and then have Fusion 360 on another, and just kind of follow his lead and do the things that he's doing over there. And hopefully they'll do it. But if there's any viewers out there that's running Fusion 360, that's a good source, and we'll put in the description area, we'll put a link. Well, Kevin's good friends with a man in Australia. Maybe some of you guys heard of him. We subscribe to his channel as well. His name is Aaron, and I believe he goes by DC Teacher 1. Well, he's got a CNC mill, a small one. I've heard of Tormac and stuff, but he's got a smaller one. It's called Skyfire, and I never heard of those. I think it's a Chinese-made one, but that piqued my interest at first, just to see how good that machine was, and Aaron likes it quite well, and so he's doing projects on that CNC, and he's another person that likes to use Fusion 360. So he's got a lot of neat things on his channel, so if you're learning Fusion 360, or if you want to look at some of these other small CNC machines, check out Aaron. And then another one I like for an entirely different reason, a guy out of Russia. And I don't know if I can pronounce his name right. I have hard enough time pronouncing English, but I believe his name's Andre. And his channel, his is quite popular. He's got, I think, if I remember right, around 170,000 subscriptions, so you may have heard of him. But he's got a channel where it's kind of different. There's a lot of neat stuff on there, so you can learn, but most of the videos you don't hear any speaking going. It's silent. He's got maybe some music going in the background, but he's telling a story. It kind of reminds me of Charlie Chaplin in the silent movies and stuff. You can see the story and what they're doing, and then he's got some other people that work with him. And then there's elements of some of the slapstick comedy, like the Three Stooges. And then he does some pretty interesting machining things that he shows on there, some things I've never seen before. So you're entertained and you get to learn at the same time. So his channel is, I believe it's Engineer Bruns, B-R-U-N-S. And I hope I pronounced that right, but if you guys want to check some of these other sources out, hey, I'll put the link in the description, and check them out and see what you think. If you guys know of any other good channels, especially if they're people that don't have a lot of subs and not popular, hey, throw them down here. I'll be happy to look at some of them as well. Well, we just finished grinding. We got a clean up cut all the way across. Let's see what happens now. And if you remember before, when we had the tangent point of our wheel right about in the center of that cut, we were big on both ends and small in the middle. So what we have over here now, we have 9/30 and 9/10. Here we have 9/32 and 6/10. So there's quite a bit of difference there. We come in the middle, we're 9/31 and 4. So what you can see now, you can see a continuous taper. We're small here and big on the end. And that's not because this is unlevel. You saw what it measured before we started, and I haven't changed anything. That's because the tangent point of the wheel, when it transverse, is crossing the center line of the spindle. And so right away you would think I got taper in here, and you're going to be adjusting up and down, and that's not what's causing the problem. We're going to do one last one. What we're going to do is we're going to do the taper, or we're going to hit the center line on this end. And again, this was the big end. 9/32.6, 9/30 and 8. So we're gonna hit the center line on this end, and you're gonna see how it's gonna give you what looks like a taper just the opposite way. Okay, what we're going to do is we're going to find the high point here. You can see I'm just barely sparking. I'm going to wind down just a little bit more so you can see it. And then I back up, and then I go back the other way. You can see as I go back and forth, I can slowly work to get that as close to center as I can. We'll just hit 0 on there. We're going to wind this back because I believe now the stock is going to be high on this end, so I'll start down here. And so you already can see what's happening, because now we set the center, the tangent point of the wheel at that end. This end's going to come out low. It's not even touching on the other side. I'm going to go ahead and take some bigger cuts just because I know it's going to be quite a bit. we'll spark this out, and then we'll see where we're at. We'll get 100% cleanup. And keep in mind, we're not adjusting the up and down to make taper. Only thing we're doing is shifting the tangent point where it's hitting on our center line. We're shifting where it's hitting the center line on the part. It's the only thing we're doing, and I have this exaggerated so that you can actually see what's happening. And so if you're lined up and you're within a thou or so, and you end up, or maybe a few thou, and you think everything's going good, but you end up with taper that you just can't seem to work out, this is the first thing I would check. And that's why I say, I think it's wise if you just get in the habit of always grinding about 10 or 20 thousandths off the center line anyhow, and in that way, it's just a nice little trick where you don't have to worry about it. If you go way too far off, then you're not going to get a 1-for-1 on your digital, but you'd have to be quite a ways off. 10, 20 thousandths, you'll probably never know the difference. But then you only have one axis to control rather than two. And in this case, if you're trying to grind on the center line that's not lining up with it, you're never going to know where you're at. Okay, so right here we're measuring 9/30 and 4/10. Here we're 9/29 and 3. And here we're 9/29 and 6. So you can see that, yeah, do it again. 929, 3.5. 929, 6. 930, 3.5. And so what you can see is that this side is big and that side is small. And the only thing that we shifted was where the tangency of this wheel and lining up the center at that end or the middle, and we got three different things. When we were lined up in the middle, we got an hourglass. When we're lined up at one end, it looks like you got a taper. And so it would be hard to tell what's happening, but if you're off center line and everything's lined up good, again, the only thing that you're going to have to adjust is up and down. So anyhow, I hope that I explained this clear enough that you can follow, but this is one of the things, if you're grinding ODs, you got a point to point, you got two tangents, you got the tangent of the part that you're grinding, you got the tangent of the wheel, and how those line up with each other will definitely affect how true the grind is going to be. So I hope this has been helpful, and we'll see you next time.